I'm going to do a few of the problems in Part H for you here. And Part H is about conversions of units. The ones I'm going to do for you here in Part H are number 2, number 4, number 5, and number 8. Those are the ones that I'm going to do for you right here. 2, 4, 5, and 8. To do these problems, you have to use the given information which is over here. Now, it's important for you to understand that this given information are made of definitions. These are all definitions. They are not measurements. So you do not count the significant figures. These are not measurements, they are definitions. So the significant figures that you count are the measurements. So, for example, in 6,300 millimeters, that's a measurement. So there are 2 significant figures here. You count those. Let me start with number 2. Number 2 says 6,300 millimeters. 6,300 millimeters. We want to convert that to meters, so I use the definition that's given. The definition is 1,000 millimeters is 1 meter. That's the given definition. In the given definition, an equal sign was used, but I turned that into a fraction. This fraction is called the conversion factor. And the reason why I turn it into a fraction is because I want to treat the mm as though it were an algebra variable, like x. So if there's an mm on top and an mm on the bottom, well, they can cancel out. That leaves me with just the m. And that means the answer is going to be with an m on it. And that means it's going to be the right answer. 6.3 meters. All right, that's how you do it. Let me make this a little smaller here. Okay, maybe I can get some better resolution. I'm going to do number 2 now. Number 2 says determine. That was number 2. I'm going to do number 4 now. How many seconds are there in 6.3 years? This one requires you to use your common sense. So 6.3 years. 6.3 years. Now, I need a conversion factor from my common sense. I happen to know that in 1 year, there are 365 days. Notice how I have days on top and years on the bottom. That's only because I want to be able to cross out the years. Years on top, years on the bottom. I can cancel them out by pretending that the y is an algebra variable. What about days? I need to convert, eventually the days have to get converted to seconds, but to do that, let's see, I can take days, and I know that in 1 day there are 24 hours. Is this how I should arrange my conversion factor? Well, no, because the days don't cancel out here. I need the days to cancel out. If I were to do the problem like this, I would end up with days squared, d squared on top and h on the bottom. That's not what I want. So I need to flip that upside down and say 24 hours is 1 day. See, that way I could have the days cancel out. And I know the hours, same thing. 1 hour is 60 seconds. Okay, hours cancel out. And, I'm sorry, 1 hour, not 60 seconds. 1 hour is 60 minutes. Minutes, right? Hours cancel out. And now the minutes, can I say 1 minute is 60 seconds? Well, no, because I want the answer to have seconds on top. But minutes are on top, so that's wrong. I need to flip this around so that 60 seconds are on top. 1 minute is on the bottom. When 1 minute is on the bottom, I can cancel out the minutes. And now I can just do this on a calculator. Here's one. 6.3 times 365 times 24 times 60 times 60, 198 million something. Now, what about the significant figures? It looks like this number right here has one significant figure, but it doesn't. This is a definition. It's not a measurement. So you don't count significant figures here. Some people say that measurements are exact numbers. Definitions are exact numbers, and so they have infinite significant figures. You can think of it any way you want, just don't count the significant figures. What we want to count is the significant figures right here in the given information, which is a measurement. So there are two significant figures there. Where's the mouse? Here it is. There are two significant figures there, and so 198 million becomes 200 million. Now, that's seconds. Now, there's no way to know, by looking at this 200 million, that it has two significant figures. It looks like it only has one significant figure. That's okay for Chem 65. There's another course at this school where you will use a line of some sort to show which numbers are significant, but in our course, you just leave it like that. If you really want to show that there are only two significant figures, you should use scientific notation, because scientific notation only keeps the significant figures and nothing else as the first number. All right, so that's number 2. I'm now going to do number 4 for you. In number 4, how many Oh, that was number 4, sorry. I'm now going to do number 5 for you. 3245 cubic centimeters to liters, all right? So, 3245 cubic centimeters to liters. Now, I'm doing number 5 for you because this cubed is a little confusing. We're going to use exponents like that on units in another homework assignment, but not on this one. In this one, you don't have to play with that much because there is a conversion factor given at the top of part H of the Math Review worksheet that says 1 cubic centimeter is 1 milliliter. So you can just convert that right away. There's another conversion factor that says 1,000 milliliters equals 1 liter. You can convert that right away. And then there's another conversion factor on the sheet that says 1 liter is 1 cubic decimeter. So you see, I didn't really have to use the fact that the 3 means cubed. I just used the conversion factors directly without ever needing to cube anything. I just copied down the 3, but didn't really have to use it. So this ends up being 3.245 cubic decimeters. Now there's another way to do this, but the other way I will show you in the future homework assignment where you need to use that other way. This is the easiest way to do this problem here for part H. Now I'm going to do number 8 for you because it's one of the harder ones. Number 6 and number 7 require also some thinking where you have to convert this number into kilograms, and then you can add those two numbers. Here you have to subtract these two numbers first, and then convert your answer to milliliters. But here, you've got to convert the grams to kilograms, and you've also got to convert the cubic centimeters to cubic decimeters. So you've got to do two things on the same measurement here. So 11.34 grams per cubic centimeter, you should take that as a measurement. So 11.34 grams per cubic centimeter. Now when it says per cubic centimeter, what that really means is 11.34 grams are in 1 cubic centimeter. It's important that you understand that it's okay to put a 1 down here, alright? Now I'm going to work on the top part first, the grams. So it says at the top of the page for part H that 1,000 grams are in 1 kilogram. Alright, so we can get rid of the grams like that. It also, I'm done with the kilograms. I have kilograms here, that's good. I'm going to keep those. I'm not going to cross that out. Now I'm going to work on the bottom here, cubic centimeters. It says that 1 cubic centimeter is 1 milliliter. So cubic centimeters, we can cross that out. It also says that 1,000 milliliters is 1 liter. Okay, so we can cross that out. It also says that 1 liter is 1 cubic decimeter. So we can cross liters out, and notice I've got cubic decimeters on the bottom here. And that's what I wanted, because in the problem it asks for kilograms on top and cubic decimeters on the bottom. So the answer is just going to be 11.34 with 4 significant figures, kilograms over cubic decimeters. There they are, the kilograms, right there, over the cubic decimeters, right there. And that's how you do numbers 2, 4, 5, and 8. Now you can do these problems in any method that you like. I've just shown you the method that is most useful for chemistry class. If you learn this method, the rest of the class will be very much easier for you to succeed in. Thank you.